Hello everyone. In this video we are gonna do face recognition. Now there are two ways to do that. First one is with the help of OpenCV library by using cascade classifiers. Another one, the more simpler one, is with the help of face underscore recognition library. With the help of it we can do easily on images. Now we are gonna use OpenCV here also, but the purpose for it here is to read video frame by frame that is in images so that we can apply face recognition functions directly on those images. Now, before beginning, you must install these two libraries. You can install OpenCV easily with the help of this command. If you can't, you can check it in the other video. I'll provide link in the description. Now, you can install face recognition with the help of this command pip 3 install face underscore recognition. Okay, but maybe you might get a problem that dlib files are not present. In that case, you could resolve it in two ways. First one is by installing cmake. Pip3 install cmake and then you could attempt to install face recognition again. If the problem is still not resolved, the best way to do is here is a link. You can find this link on the website www.devrush.net. You will also find the entire code for this tutorial there. Now, just go to this link, download the zip file for the code, extract it, go inside the folder, and in that folder, in the terminal, open any terminal, whether it be command shell or PowerShell, and run this command python setup.py install. It will install all the dlib files from GitHub. And after that, you can install facial recognition again, and it will work fine. Okay, and after that, let's begin coding. Now, first of all, let's import the libraries. Face recognition as FR. Now, before beginning, let me give you a brief heads up that what we are gonna do. First of all, we are gonna load the several images whose faces are known to us. Like for example, here I'm gonna load my image and then John Cena's image. Okay, and after that, in the live feed, we will load all the images again frame by frame in the video, and then we will compare the faces detected in the live feed to the faces with the names that we have already stored before. And if any of those faces match, we will show their names from here. And after that, if they don't match, we will show that all those faces are unknown to us in the live feed. So first of all, we are going to work on the known faces that are known to us by finding their distinct qualities, that is their encodings. Now let's begin that. Let me name a variable Rushil, that is my name, equal to fr. Now we are referring face recognition as fr dot simple function load image file. In that, first of all, we have to give a path of that file. Now I have the file in the same folder, so dot stands for to check in the same folder. I have copy pasted my file in the same folder. Its name is Rushil0. Let's load it. After that, now let's save its encodings. Now basically encodings are the features of the face like its shape, color, gap between the eyebrows and all the features combined. It is basically a 128 dimension array encodings for all the faces in the picture. And here, since this is my personal picture, now I load John Cena's picture too. It will be there only one face. Okay, so it will return an array, but it will have only one element. So right now what we are gonna do is encodings equal to fr dot face encodings. In the bracket we have to first specify the face image, and then we have to specify if we already know the locations of the face, which here we don't know. So let's just specify the image name, that is rushil. Image is stored here, and here we are gonna give zero index, that is fr.face encodings will return an array and we will store the zeroth element. There is only one element, but we need to store that element in the Rushil underscore encodings file. After that, let's do same for the John Cena. Again, his file is available in the same folder, John. Uh, Again, 0th index. Let me show you the image also. This is the image. Now after doing that, what we need to do is let's store all the known faces and their with their names and their encodings in just one list. So let's name it known face encodings equal to, which is a list. First it will store my Rushil underscore encodings, comma John underscore encodings. Now in the same order, let's store their names too. Time to capture the live feed. First of all, let's define some variables. Face locations. We are gonna need all these variables inside our while loop when we are capturing the live feed. Face encodings. All these will be used for our frames in our live feed. And face names. Now we are also going to use a variable named flag. The reason for using this is what we are going to do is in order to make the process faster, in order to apply the processing on all the frames, we are going to apply it on alternate frames. Like for example, if I process the first frame, I'm not going to process the second frame. I'm going to process the third frame. So after processing, that is after loading each frame, I will reverse the value of flag and will only apply all the operations if the value of flag is true. So let's do that now. Cap equal to cv dot, again we are using OpenCV just to read the video from our source. Now let's begin getting the video. While loop, it is an infinite loop to read the video. This is the ret variable, we don't need it right now. Frame equal to cap dot read. Basically 0 is the source for our live feed. If you have any other source such as phone connected to it, you could use 1 here, that is the number of the source. Now this will read the video captured. Now let's resize this frame. We are resizing it just to make the process a little bit faster because it is quite a complex process to be performed, the face recognition. The name of the frame that we are going to resize is frame only. Uh, it will start from 0, 0, and let's make the image 1/4 of it. So let's specify fx equal to not 1/4, let's make it half of it. Now this thing will make the process of face detection significantly faster. And we need to do one more thing. See, the thing when we read image with the help of OpenCV, we read it in BGR format, that is blue, green, red. And when we load the image file from face recognition library, we do it in RGB format. So in order to perform the face recognition functions, we need to convert this small frame into RGB format. Again, we are going to use OpenCV for that purpose. CVT color, convert color function. First of all, we have to specify the source, that is small frame only, and then we have to name the function, that is the process we are going to use for this conversion. cv dot color, here you can see it, bgr to rgb. Now the entire code ahead will be inside the flag. I already explained you the reason for using this flag. First of all, let's store the face locations. Now you might wonder that why we are storing face locations here and we didn't do them for our images. The reason behind that is we are gonna mark the faces in this frame, that the face is present here. If there are 5 different faces, we need to have all the locations to make a rectangle around those faces. So that's why we are storing face locations here. There is a direct function for it, fr dot face underscore locations, and in the bracket we have to specify the name of that image, small underscore frame. Now let's store the encodings for this face, fr dot face encodings. you can see it takes many variables. First one is image, then known face locations, which are known this time, and it will make the process significantly faster if you already know the face locations, because it doesn't need to find the encodings in the entire image for the faces. So the name is small underscore frame, comma, face locations. Now here we will be storing the face names. Let's make a list for that because it's time to compare the faces. Now for basically this face encodings variable will have many values for all the faces. Like here we use the index 0 na, even though the size was 1. Here we have all the faces available in the current frame. So we will have to do for face underscore encoding. That is, we will have to compare all those encodings one by one to the known face encodings that we already have stored in over this list. For face encoding in face encodings, matches equal to fr dot, I'm sorry, compare faces. Now first of all we have to specify the list, that is the known face encodings is entire list. Now we have to specify the current face encoding which will be compared to all these encodings and find out if there is a match. If there is a match, it will store true in place of that, and if there is not, it will store false in the matches. Matches is also a list, face underscore encoding, and currently the name is unknown. That is the by default name, that is if we don't find any matches, because we haven't compared for those matches yet. Now there are two ways to do that. First way is, like, we could check that if there is a true case in matches, we can find out the index directly. But here what I'm gonna do is perform a double check. That is, use the face distance method. Now when I'm doing face distance for any image, what it will do is return a distance, that how similar is this particular face to the face I'm comparing it to. So if the distance between two faces is very less, that means they are very similar, and if it is too high, that means those two faces are very different. So basically face underscore distances equal to fr dot face distance known face encodings, comma, face encoding. What it will do is, for the current face encode all the face encodings, it will find out if there is a, like, it will find what it will do is, for all the for this particular face encoding, that is for this particular face, it will compare it to all the known face encodings again and store their distances in this particular list of face distances. And what we are gonna do is, we are gonna find out the minimum face distance and find out if that case was true. So it is double check. Like, if that case was true, that means the compare face already returned that those two faces were similar. And right now what we are doing is finding out the distances. That means if the case is actually true, then that distance should also be the minimum. So we are comparing the current face in our frame to all the known face encodings. Now, in order to find out the minimum, we need another library, Numpy. You could install it directly by pip3 install Numpy. We are gonna import it Numpy as np. Now we will store the best match index. There is a function in Numpy, argmin. What it does is, it will return the index of the minimum argument. Here we will specify face distances. So by default, the best match index should be the most close to the known face. We already know the index to which face it is close to. After that, what we need to do is that the double check thing. Now this, in for this index, the matches, the element in that matches should also be true. So the double check is done, and that means for sure that those two faces are alike. So we are gonna do that test here. Matches, inside the matches, at the index, best match index. If this one is true, then in that case, name of that person will change from unknown to, I'm sorry, known faces. It has names of all of them at best match index. And I will do one more thing, because we are storing all the face names in the list, face names dot append name. Now after this works properly, what we need to do is reverse the value of flag so that it doesn't execute two consecutive frames to make the process a little bit faster. Now what's left is to draw a rectangle around those faces, and we already have the face locations of all the faces. And now if they had a match, we will show the face name, and if they didn't, we will show that their name is unknown to us. Now in order to make the rectangle, let's make a for loop again. For top comma comma bottom comma left in zip, wait, comma also the name in zip, face locations comma face names. Basically, the purpose of zip is a class. Now, when we need to iterate two iterables together, we use zip. So, for example, when it is doing the first iteration, it will go through the first iterable, like first element of face locations and the first element of face names. When it is going through the second element of face locations, it will also be going through the second element of face names. That is, it iterates the two iterables together. Face locations and face names are both iterables. Now let's begin to draw the rectangle. Now first of all, what we need to do is all these locations are for the half of the image. You see here that we have resized the image. So let's multiply them by 2 now to get the actual locations of the faces. After we have done that, we could draw the rectangle easily. Now if you have any problem in drawing the rectangles and all, you could check out the another video where I have described properly how we can draw geometric shapes. I will try to explain it in brief here also. Now we have to draw the rectangle on frame. Now I will explain in brief here. What we need to do is specify the two coordinates here for the two corners of the rectangle. First coordinate is the upper left corner and the another coordinate is bottom right corner. And when we specify those 2 points here, it will draw a rectangle on them. So left topmost corner is left comma top. Coordinates for bottom right corner is right comma bottom. After that we have to specify the color. Let's use red color here. BGR 0,255. Let's use the thickness as 2. Now let's display the name here only. CV dot put text in frame name. We have to display text below it. Left plus 5 comma bottom minus 5. Now font, we have to specify the font face. You can use default many font faces available here. Just type CV dot and you will see font Hercules, simplex, complex, plain. Let's use the simplex, the first one here. After that, font scale, let's just say it 1. And then we have to specify the color. Oh, I'm sorry. Let's use white color here, 255, 255, 255. If you mix all the colors, it will be white. Then thickness should be around 1. After we have drawn the rectangle, let's give a little bit shade also so that it looks better. CV dot rectangle, we will draw another rectangle and fill it with color, and text will be displayed inside it. It will look a little bit better that way. There's no need to do that, but we are doing it, so just it looks good. Frame, comma, left, comma, bottom minus 30, another coordinates, right, comma, bottom. Now let's use the color as 0, comma, 0, comma, red color only, thickness as 2. That's it. Now after drawing the rectangles, let's display it. cv.imshow, name of the window, face recognition. We have to display the frame here. Now key equal to cv dot weight key. If you have any problem what weight key does, you could check out another video. I'll provide same video where I have explained geometric shapes. I have explained it in detail how this key works, weight key. 27 is the sky character for escape key. What we are doing is as soon as we press the escape key, you should exit out of this while loop. Break. Now as we exit from the while loop, we need to first of all cap.release, that we need to release our webcam source, and after that we need to destroy all the current open windows. Okay guys, let's make a few more changes. Just make sure one thing, that when you are putting the text, you have already filled it with color, because the last rectangle that we are using for shade, text should be above it. So just copy, cut, paste this command after this line. And it should be bottom plus 30. It's a typo. It shouldn't be minus. Now let's check if it is working properly or not. It takes a few seconds to load up. It's a little bit slow. Okay, it is working properly. Great.